Hello and welcome back to the Inside Java podcast, a podcast about everything Java brought to you by the team that makes Java. In this episode, we will discuss Java 15, which is being released as we speak. And today, our guest is Mikael Vidstedt, Engineering Director of the JVM here at Oracle. Mikael, welcome.
Thank you very much. Happy to be here.
So, Mikael, first of all, tell us a little bit about yourself. How did you end up doing what you are doing today?
Oh, yes, that's a good question. So I have been working with Java for my entire career. This all started with me joining a startup in Stockholm, Sweden, 20-something years ago now. So it was a small startup working on JVMs. We were developing a JVM called JRocket, and we were competing with Sun and Oracle and IBM and other big companies. And that's sort of how my whole Java career started. We got acquired and got acquired again, and I ended up at Oracle, but it's been JVMs throughout my whole career.
What are you doing today? You are running the JVM team, right?
I am indeed running the JVM team. So I call myself officially, I guess, director of the Java virtual machine at Oracle. But basically what that means is working with a bunch of talented, great people and trying to coordinate what's going on in the JVM, both technically and somewhat more on the execution management side of things.
Okay, cool. Today we're going to discuss Java 15. So Java 15 is the second release of Java in 2020. It's the sixth release under the new release cadence. So I'd like to have your opinion as an engineering leader in the Java platform group on this 6 months release cadence. So what are the benefits, if any? Does it pay out? Or maybe was it simply a bad idea?
Yeah, no, it was certainly not a bad idea. So from my perspective, sitting in the team I am, in the group I am, the new release model has just made all the difference for us. In the past, we used to be proactively stressed up about what was going to happen 2 or 3 years later. So we were trying to proactively plan our releases and make sure that the right features were in the right releases and were ready in time and all of that. And that was, as you might imagine, very, very challenging. It's extremely hard to predict, obviously, what's going on in our industry and how long things will take and all of that. So the new release model we basically turned everything around and said that when things are ready, they go in. Before that, we don't even try to make predictions. Well, we can make it for fun, right? But it's not a sort of a requirement to plan ahead of time. And basically that together with the fact that we're now doing releases more often means that we are actually more relaxed. It's much easier to be a manager or an engineering leader in the Java ecosystem right now, I think, in general. They normally say, if it hurts, do it more often. And I think nothing has been more true about this, right? We're doing releases so often right now, every 6 months, that it has all become sort of a well-known pattern. We know exactly how to deal with things and things just happen automatically. And, at the very end, we have this, ramp down phase we go through, and there are a bunch of bugs that need to be ironed out and all of that, but it always feels like we're on top of things. And that's very, very nice. Like it allows us to spend time on arguably the more important things, which are like, which features should we be working on? What's the right thing to do for Java long term, rather than, the short term sort of deliverables going into specific releases. So it's been extremely, extremely nice for us working on the Java platform itself. And I like to think that, as a user, customer of Java, you also get now features more often, right? It doesn't take 3 years to deliver something. You can get them, every 6 months, there's incremental value that we deliver. And that means that you can get access to these new features and the new functionality more quickly. So I like to think that for everybody, this has been a very good change. And I'm very happy that we made it.
Good to hear. Now, let's talk about Java 15. So we are in September 2020. Java 15 has just been released. So we're going to quickly look at what Java 15 brings. So first, on the Java language and on the JDK API side, we have multiple new API or updated API. So the first one is Seal Class.
Yeah, no, the seal classes is one of those things that it's a primitive in the platform itself that a lot of people may not, notice or care about all that much. But what it does allow is for us to build very exciting functionality on top of it. So basically what it does is to have a controlled way of saying which types can extend other types and things like that. This helps us in developing a lot of the other functionality we have in the pipeline going forward. So it's a very exciting but very sort of low-level primitive for building things on top of. And it's in preview mode in JDK 15.
Next, we have hidden classes, which is a bit more special as that feature doesn't really target the mainstream Java developer.
No, this is true. This is even more of sort of an internal platform thing. This feature in particular is one of several in which we're trying to, piece at one step at a time, sort of replace the unsafe functionality that many libraries and frameworks have come to rely on. So hidden classes is one primitive those libraries and frameworks can use to define classes that are effectively sort of hidden. They cannot be looked up. They're not normal named classes. In essence, again, this is one of those like background features that we will build functionality on top of, but few people will actually notice this on a higher level.
Yeah, probably framework developers will use hidden class.
Correct.
Yeah. Then we have in JDK 15 JEP 373, re-implementing the datagram socket API. The important thing about this API is that it is in fact some preparation work for Loom.
That is correct. So Loom is one of the very exciting projects that we have in the pipeline that we've been working on for, what is it now? A few years, 2-3 years, something like that. And effectively what it allows us to do is to provide a very lightweight new threading model in the Java platform and significantly simplify the way that libraries, frameworks, and applications need to implement code to leverage threads and parallelism. And as part of that, one of the things we need to do is to modernize the platform itself. Threads going forward are going to be much more efficient, but that means that we need to loosen up a few of the things that we have been doing internally and make sure that, especially for socket and file operations, that sort of thing, that they're now prepared to deal with threads in this new world. And the replacement of the datagram socket API is one of those pieces. So the re-implementation there is, as you say, a prerequisite to the Loom project that is coming going forward.
Yep. Okay, the next one, JEP 378, text blocks, standard features.
The exciting thing here is obviously that in many cases what you see is that in Java code, you need to in some way encode text or a blob of data in some way. And traditionally what that has meant is that you need to do a lot of escaping, figuring out exactly where to put your backslashes and new lines and all of that stuff. And what text blocks allow you to do is to basically do inline blocks of text. So several lines of text that are where you don't need to do the escaping. You can just type the text in and it will appear and be handled exactly like it's typed. So you see what you get, sort of thing.
And also regarding text blocks, so I've noticed that OpenJDK starting 15 is using text blocks for the test. So
good.
Text blocks can be used to embed any kind of structural language. So OpenJDK used that to embed directly into Java code, but also HTML.
Yes, that's awesome.
That's a good example of eat your own dog food.
Yes, absolutely. And I mean, obviously for many of these features, in the end, what we're trying to do is to make end users, developers more efficient. But of course, it's also always a nice bonus when we can leverage that same functionality ourselves to make ourselves more efficient. So glad to hear.
Next up, we have the foreign memory API, second incubation.
Yes, this is an exciting one because this is coming out of a project called Panama, which in the end, Panama is a pun on the fact that we either, the country Panama either connects continents or oceans, depending on which way you look at it. And in this case, in our world here in the Java land, what we're connecting is the Java world with the native world. So think native libraries and other non-Java implementations, libraries, things like that. I actually used to work on Panama a few years ago. So I'm very, very happy to see that we've made now progress enough so that we're putting this as an incubator feature in JDK 15. And very much looking forward to seeing other things that we build on top of this. Part of the reason why we're investing in Panama is to enable use of, for example, machine learning libraries, so things that already exist, that are implemented in other languages or libraries right now, and that are harder than ideal to get access to from Java. So this is a step on the way to enabling and leveraging those libraries very naturally from Java.
The foreign memory API enables to access safely and efficiently native memory from Java.
Correct.
But that's something that we can already do today through GNI or Sun, Misc, and Safe.
That's right. So you can today, as you say, you can either access memory through using JNI libraries or through unsafe. Now, we are trying to obviously replace unsafe with safe alternatives. And also, if you choose to go down the JNI route, you quickly find that there's a lot of sort of hassle getting JNI code working. So you need to go through this dance of using a tool and finding the native tool chain to build the library and things like that. In the end, what this functionality, what Panama is trying to provide, and what this JEP is one step of the way there is doing is for the memory access, the data part of that, we're providing Java APIs to do so. So you don't need to go in and compile your own native libraries and do C, C++ header files and those scary things that nobody should have to deal with.
Yeah, exactly. Next, and last but not least, we have records, second preview.
Yes, and this is actually, I think of the language level features, I think this is actually my favorite. There are a couple of reasons for that. So records is reducing sort of the amount of code you need to write for the common cases of Java code. So what basically they allow you to do is to define a very small class, which is immutable. The only thing you need to define is more or less the fields, or I should say the class name, obviously, as always, but the fields, the types and the names of the fields. And all the other stuff will be automatically generated for you by JavaSee. You don't need to type that out. So for example, you don't need to do the accessor methods. You don't need to explicitly write them. You don't need equals and hash code and all of those other things. And what I like about this feature, apart from the fact that it's, cutting down on a very common case, reducing the amount of boilerplate you need to write for a common case of Java, is also how it's in line with many of the other features that we're working on. So it's a step towards providing pattern matching for the more general cases, serialization, a new form of serialization where the platform knows how to automatically deserialize types and things like that. So it is in itself very powerful, but it's also, in my mind, really awesome because of how it fits into the long-term story.
Yeah, I agree. And the thing with records is as soon as you start to use records, well, you can't live without records.
Yes, that's
my take on records.
I believe that. But when I write Java code, I've always tried to do it in sort of a records styles, like immutable classes and trying to make sure that it fits into this new world where we're trying to keep data immutable, not changeable. Getting access now to records is going to be revolutionary in my mind. Very cool functionality.
Yeah. So records in JDK15, second preview. So there are a few new features, including support for local records.
Ah, yes.
So that's something which is also quite useful. Now, you've mentioned pattern matching. In JDK15, Java 15, we have JEP 375, pattern matching, for instance, of the second preview.
Yes, this is also one of those boilerplatey reduction things, which again leads into the more long-term roadmap we have as well. So today in Java, it's not uncommon to see the pattern where you first do an instance of, and if the instance of succeeds, you'll find that in the statement after that, the first thing you do is cast the type to the target type. And that pattern is sort of so common and frankly very annoying to write every single time. So what pattern matching for instance of allows you to do is to, in one single expression, in the if expression itself, you can say X instance of point P, for example, or maybe that was a bad example, but basically you do the cast, the definition of the point, the more specific type, that gets set up for you automatically in that expression. And then in the actual if body, you can use that automatically. So you don't need the second statement that does the cast. And this is one of the, again, examples of the more long-term roadmap we have for Java here in the language, making it more and more compact or less verbose, less boilerplate that you need to implement to do the common patterns. We'll see more of that going forward.
Yes, exactly. So pattern matching, for instance, of text blocks or records are all part of Project Amber.
Yes, Amber is where we do a lot of the development of language features that are in the end trying to improve on the Java language and make it more readable and for that sake writable, of course.
Let's move on to the JVM space, maybe a space that you are more comfortable with, hotspot.
Yay, yes, I've heard about that.
Yeah, really? So there has been a lot of excitement around the GC space recently. So can you tell us a little bit about what has been going on?
Absolutely. So GC is always an interesting one. It is one of the sort of secret weapons, if you so will, of the Java platform. So obviously, with what GC allows you to do is to allocate objects and do, you don't have to care about memory management. The Java platform takes care of that for you. And for the longest time, I want to say, we saw improvements on the GC side, but not necessarily revolutionary improvements. So there was certainly a lot of work that went into GC in general. But the exciting part about JDK 15 is that we're now actually seeing two new production-ready GCs. So the two GCs are ZDZ and Shenandoah. And they're both trying to target sort of the same general space. So low latency, low pause times or short pause times. Everything from relatively small heaps up to very large ones, so terabyte large heaps. This is sort of a long effort. We've been at this for a very, very long time. So ZDC specifically, I think we started working on that 5 years ago or so. So this is not just a new GC. As a matter of fact, a lot of the work that has gone in is improving on the other parts of the runtime, not the GC specific parts, but the other parts of the runtime, to make sure that there are no places where we have long pauses. We've cut down on everything from how you find all the objects that all the operations that the GC needs to perform, but also the other parts where theoretically, the JVM will stop threads. It will perform certain operations, and that may lead to latencies for your application. It will effectively look like the application is stopped. So a lot of work has gone into this, and it's culminating now with JDK 15, where we're seeing the production-ready version of ZDC, for example.
Because ZGC was, if I'm correct, was introduced as an experimental feature on Linux x64 in JDK 11, right?
Yes, that may well be true. As we discussed earlier, the fact that we now have releases every 6 months means that it's really hard to keep track of exactly which one, which release something went into. But you are most likely correct. It's been a while in the works for sure, and the way we normally roll out these features is that they go in as experimental or something, and then as they mature, we move them into production ready, and that is where we are today with ZDC. So very happy to see that has gone in now.
So ZGC JDK 15 support Linux, ARM64, Windows, and also macOS.
Correct. All the platforms that we ship from Oracle are supported. Yes.
Okay. Now that we have ZGC as a production GC in hotspot, what does that mean for G1, which is the default GC?
Yes.
Does that mean that G1 will go away?
No, absolutely not. So the challenge we have with GCs in general is that there are always trade-offs. So, depending on your exact use case, you may want to have different types of GCs. So in the past, the default GC in the JDK was the parallel collector, at least in most cases, I should say, to be complete. And basically what the parallel collector does, and the parallel collector, by the way, is still in the JDK. You can still run with it. It isn't the default anymore. The parallel collector provides really good throughput performance. So if you are running batch jobs, for example, and you don't care so much about latencies and pause times, then the parallel collector will likely be the best option for you. It will provide the best performance and so on. What we've found over the years is that more and more applications actually do care about latency and pause times, to some extent at least. And what G1 is doing is basically providing a good default for the vast majority of cases. So it's not trying to be the best throughput performance collector. It's not trying to be the best latency collector. It's trying to be good enough for the 99% case. And that is still the case for G1. It is fitting that space where, unless you have specific requirements, G1 will most likely work out really well for you. So what we're planning on doing is to keep G1 as the default. And then keep working on ZDC to improve its performance and fit into more and more spaces over time. So G1 is there to stay for a very long time going forward.
Okay, so that means that we keep investing on G1 too.
That is correct. We have over time improved G1 a lot. And I'm very happy to see some of the performance improvements we have done going from JDK 8, where G1 was still just opt-in collector. And then in JDK 9, G1 became the default. And since then, we've improved on the performance quite significantly. So over the last few releases, you are typically what we've seen is that we improve performance by double-digit % over time, right? So we keep investing in G1 and all the other parts of the JVM, and we're seeing really good improvements there.
Cool. Moving on GDK 15. So something that one can easily notice is in GDK 15, a lot of things have been removed or deprecated.
Yes.
Yeah, I'd like to have a short discussion on that. Before we go through the list, it might be useful if you could explain how things are being removed from the platform.
Yes, that's a good one. So much like sort of when we introduce new functionality, we often go through the cycle of first making things preview or incubator or experimental. And then as we get more feedback sort of on how things stabilize and what's the right way to approach things, we polish things and then in the end they become production. And we go through a similar cycle when we deprecate and remove things. So typically what we do is that we first go through and deprecate things, which basically means that everything still works exactly like it used to, but that if you use the functionality, you get some kind of indication that it is on its way out. So you either get a warning message or we mark it in some way in the API as deprecated. And then at some point later, and this does depend on the exact functionality or piece of code, we will eventually remove it. Now, there are cases where we don't remove it because in the end, it is the cost of actually removing it is higher than just keeping it around. But then the deprecation is more a signal that there is a better alternative that you should be using instead. But that's typically the cycle. And we, again, as I said, depending on the feature, this step here between deprecation and removal can be anything from one release to many years, several releases.
Okay, so now that we know how we remove things, maybe you should explain why we are removing things. Because at the end, if we have something in the platform that is implemented, maybe it's just more cost effective and more pragmatic to just keep that feature in the platform instead of removing from the code.
No, that absolutely right. And as a matter of fact, we take backwards compatibility very seriously. So we don't remove things just because it's fun, right? Quite the opposite. We very carefully look at everything and see, is the value in the end? Like, do we think that this is the right thing to do long term, not just, because we felt like it that specific day. And there are many different reasons why we look at this. The obvious ones include things like security issues. So if there are specific APIs or pieces of code functionality that are problematic, then clearly we need to look into how we can address that. In the end, it's also just sort of an obvious fact that there are only so many resources working on the Java platform. We can only do so many things. So in the end, we do need to invest very carefully and look at where the market is going, what's happening in the world, and sort of make room for innovation.
In 15, for example, we have removed the Nashorn JavaScript engine. We have removed the Solaris and Spark ports. That's a big one.
Yes, that's actually one of my babies that I picked up and worked on. And in the end, Solaris and Spark has been with us for a very long time, for sure, right? That is one of those, it's a canonical example of something that is there and for all intents and purposes is working really well. So the obvious question is, why did we choose to remove that? Well, there's the small part of the reason, which is, well, there is still a cost to everything. So even if we just sort of keep it working, fix the small number of issues that we find, that is still cost. It's not just in the actual code changes, it's also keeping the infrastructure working, having all the machines up and running for testing and building and all of that. But arguably the more important reason why we looked at this and removed Solaris and Spark specifically is because of the sort of the long-term functionality and roadmap we have. A number of the projects we have on the roadmap right now have significant impact on CPU architecture specific code, and in particular on the Spark code. So take as an example the Valhalla inline types. That is all about performance and how we can make sure that the new types, the inline types that we're developing on the language level, are performant inside of the JVM. In the end, on the language level, this is basically just putting some keyword in front of your class and lo and behold, like you get all this performance. But what that means for us implementing the platform is that we need to spend a lot of time improving on the optimizations that the JIT compiler does and all the sort of calling conventions, how arguments and things are passed around internally in the JVM. And that is very, very CPU architecture specific. So the cost of making inline types work well on Spark, for example, is very significant. So it's one thing to keep it sort of incrementally alive, but for these big projects coming, Valhalla, Panama, Loom, all the others, there is a significant investment that we'd have to do. So in the end, we looked at this and realized that it may be better to deprecate and remove the Solaris and Spark ports instead, right? And you can still get them in the older versions of the JDK.
Okay, it makes sense. Can you give us some idea what it was to remove that?
Yes, I actually tweeted this out back in April or May or something like that. And at the time I did the math, the number of removed lines was something in the order of 127,000 lines. And at the time that added up to approximately 0.8, or let's say round it off and say 1% of the JDK, OpenJDK code base. So that's obviously quite significant and may give you sort of an indication of the amount of code that we have to maintain and support, and as I said, update for new projects like Valhalla as well.
I think that we can conclude this by saying that removing stuff is certainly not negative. It's basically an effort to prepare the future, right?
I think it's absolutely necessary, to be honest, because over time we can certainly, we add functionality to the Java platform, but there always needs to be some amount of cleanup and preparation for the long-term new innovation. And that does mean that we, from time to time, need to go in and deprecate and remove some of the existing old legacy functionality.
Okay, something that I would like to quickly discuss with you is the fact that there's basically something for everybody in each JDK and Java release. Often people look at the JEP list and they think that basically that summarizes the content of the release. So the JEP list of any given Java release only gives a global picture of that release. But in each release, there is more. So for example, if we look at JDK 15, we have on the security front, there is one JEP, JEP 339, Edwards curve digital signature algorithm. I will be fair with you. I will not ask you to explain that one. We have one security-related JEP, but if we look at the release notes of Java 15, there are more security-related enhancements than just that single JEPs. For example, we can mention that there is support for the Certificate Authorities extension, which is a TLS 1.3 optional extension. So here, I think that it's fair to say that in each release, there are many other features and sometimes hidden gems that are not necessarily surfaced through the JEP list. Is there any JDK 15 features that you'd like to highlight? A feature that is not necessarily a JEP?
Yeah, so to start with, I had a quick look, and I think, you're right that we have, I think for 15, we have something along the lines of 15 JEPs. It's 14 or 15, something like that. But if you look at the total number of enhancements fixed or integrated, let's say, it's something along the lines of 800. And if you look at the number of bug fixes, we're close to, I think, 1,700 or something like that. Those are not exact numbers, but... and that obviously shows that there's a lot of stuff that is happening that is not surfaced, as you say, through JEPs. So clearly, we do a lot of work that will not have a JEP associated with it. It's always a sort of a trade-off. What we try to do with the JEPs is highlight the most impactful or important features. But in the end, there's always more work going on in the background. So that's the first thing to note there. When it comes to specific things in 15, so one of the things I like is the work we're continuing doing on container support in Java. So obviously we want to make sure that Java runs really well, not just in normal environments, but also in container environments. And as part of that, one of the things we did in JDK 15 was add support for C groups, version 2 specifically. And this is just an example of sort of an effort that in the end, you as a user probably just expect to work. If you fire up your Java in a container, surely it will just work in the background. Now, we didn't have a JEP for this. It's just a sort of a normal feature, but it's an important one. And this is also sort of in line with, we actually had a project dedicated to this called Portola. So a project where we were looking at improving in general support for containers, and in particular for some of the other types of Linux distributions that are more commonly used in containers. So in this case, we had Portola was looking at providing a port of the JDK to the Alpine Linux distribution. More specifically, it's actually to a version of the C library called Muscle, which is different from the GNU C library that most Linux distributions come with. So those are sort of a couple of examples of work we're doing that may not bubble up, and you may not see them in the list of JEPs, but it's still important, and just good improvements that we keep doing.
Right. Now, if we zoom out, 2020 gave us two releases, Java 14 and Java 15. Is there anything either in 14 or in 15 that you'd like to highlight?
Well, so being the JVM guy, one of the things that I'm always, looking at and, feeling good about is when we can provide more insight into what the JVM is doing. It's like, how do we make sure not only that the JVM works, but if you run into issues that you can easily diagnose and get more information. And as part of that, we have a project that actually this comes back to, my early days, 2005 or so. We started working on something called Flight Recorder. That is functionality that we over time have integrated now into the hotspot JVM, and over time worked on, making sure that it works really well and is performant and all of that. So right now, in JDK 14, we have added support for something called JDK Flight Recorder event streaming. And basically what this whole framework does is allow you to get very, very fine-grained and detailed information out of the JVM. So what is happening inside? Like which methods are compiled? What are the details around the garbage collections that happen? Which locks are being taken, acquired, and released? That sort of thing. And you can get that with extremely low overhead. Now, in the past, this has been true. JFR has been there for quite a long while. The new event streaming functionality that went into JDK 14 is what I consider sort of the last important piece of the Flight Recorder functionality to, in my mind, really call it like production ready. We have the whole first version of the whole package. Because in the past, you had to store the information down to a file and then post processes afterwards. But with event streaming, what that functionality allows you to do is to online, you can have a stream that you constantly process. You get these events, all the stuff that is happening inside of the JVM, you get that and you can do processing on it in real time and draw conclusions and things like that. So event streaming went into 14 and that's really exciting functionality in my mind.
Yeah, it is. Michael, I think it's time to wrap up. This show is called the Inside Java Podcast, so let's give our listener a look inside. So what does a typical day in the life of Michael looks like?
Yes. So Michael wakes up, he gets his cup of coffee as quickly as possible because Michael likes coffee a lot. And then Michael typically goes to work, and, in COVID days, that means, stepping into my home office. And I fire up my Slack and my email and check what's going on and all of that. And then I am a manager, so typically there's a meeting or two in the morning. We're a distributed organization, so that typically means that a lot of the meetings happen in the morning, my time on the West Coast. And once I'm done with my meetings, I am, after all, an engineer. So the first 17 years of my life I wrote code, and I still enjoy that part of it. As a matter of fact, the JVM space is just a very fascinating and never-ending source of new, interesting puzzles and challenges. We do all of that so that users and developers of Java don't need to take care or care about the details of the platform and CPU and operating system and all of that. So I thrive on that, and I do try to spend as much time as I can still working on code and implementing things, helping out with various things. But in the end, what makes my life most exciting is all the people I work with, because there are brilliant, absolutely brilliant people in the Java community and space. There's a lot of brain power around, and combined with the awesome technology that the JVM and Java is, my life is never boring. I always wake up, and look forward to what's going to happen and, what awesome stunts we'll pull off today. So life is good if you're Michael.
Cool. Thanks, Michael. It was great to have you as one of the initial guests of the Inside Java podcast. I hope you will come back.
Thank you very much for having me. I certainly enjoyed it.
Great. Thank you.
Thank you.